Okay, we are learning some stuff about when the function is greater than or less than 0. So what we're interested in is when is the graph. So these are the things that we want to know. When is it equal to 0? When is the function less than 0? And when is the function greater, than 0? So what we're saying when we say this is, what are the y values? When are the y values negative? If I say, when's the function less than 0, I'm really asking, when are the y values negative? And when I say, when's the function greater than 0, I'm really asking you, when are the y values positive? Right? Now then, you can tell because you know positive numbers are up here on this top part. Up here, all these are positive numbers. Right? So I know that the y values are positive when I'm above the x-axis. And I know the y values are negative when I'm down here below the x-axis. So the question that they're asking here, they want to know three things. And so if my question is, when is the thing equal to 0? When is the function equal to 0? Well, that's equal at the x-intercept. And in this case, the x-intercept happens at 0, 0. So the answer to this, when is f of x equals 0? That's when x equals 0, right? That's the x-intercept. We're done with that one. What about this one? When is it less than 0? So now I have to look at when is it below the x-axis. Well, there's only it's only below the x-axis over here on this side of the graph. So if I change my color here, let's change to this color. This part right here is the part that's less than 0. And so you have to tell me the x intervals, right? This is all x values. What x numbers can I pick that make the y values less than 0? That's what I want to know. So it's an x interval. We're looking for the x interval, right? The x interval. So let's go back to my other color. So that means when I pick numbers that are in between 0 and this vertical asymptote, the vertical asymptote, look, they're counting 2, 4, 6. So between 0 and 2, that's the only time that this graph is below 0. Right? Think of it like a thermometer, below 0. The only time that the graph is below 0 is between 0 and 2. Okay? Whoops, what happened? There we go. So let's do the other one. When is the graph above 0? Well, I can see that it's above 0 for all these numbers. Every negative x number I want to pick up to I get to 0, that's when it goes down, right? So from negative infinity to 0, and then again, after this asymptote, all of this graph is above 0. This whole graph here is positive. So that means after 2, it's positive, right? So our question is, when is it greater than 0? There's two sets of x numbers, two x intervals that make it greater than 0. There's one x interval that I can pick numbers in between here that make it less than 0. And there's only one time when it's equal to 0. That's at the x-intercept. Okay? Let's do it again. Let's just see if we can understand and do it again. We'll look at the one next to it. So that means we've got to clean this out. Where's my eraser? I lost it. Okay, so we'll go. All of this needs to go away. Okay, there we go. Get rid of that green stuff. There we go, go. All right. So here, I know that the x-intercept is at 3, right there. Right? The x-intercept's at 3. I can tell that there's an asymptote at -1. The vertical asymptote is at -4, excuse me, -4. Okay, so what I have to do is I have to split this. Let's do it this way. I have to split this. This is the x-axis at -4. And then at the x-intercept, which is +3. And then that's the places where it's split, right? Now, you can tell that everything on the left-hand side here is negative, right? All of this between -infinity to -4, all of this is negative. The whole thing, that's all negative. You agree? Yeah. And then in between -4 and +3, here, let's get that bright green stuff again, huh? I can tell that this is all positive. This whole graph from here, this is all positive y values. I'm using all these positive y values. So it's positive whenever I'm in between -4 and 3. So we'll just write -4 to 3, right? That's when it's positive. And then when's it negative? And then it becomes negative again, right? So it becomes negative again because if this is the x-intercept, it's going below because, see, it's getting closer to the horizontal asymptote. So from 3 to infinity, it's negative again, right? So if I was answering these questions, when is it equal to 0? Well, there's only one time it equals 0. So it equals 0. The function equals 0 when x equals 3. How do I know that? Because that's the x-intercept. It says so right there, right? That's where it says that. And it says so right there, too, right? That's the x-intercept. All right. When is it negative? Well, there's 2 times that it's negative. See, right here, we know this is down below the x-axis. So it's negative from -infinity to -4. And then it's below the x-axis from +3 to infinity. So it's negative on this side and it's negative on this side right here. Negative right there, it's negative right there. So the only time that it's positive, f of x is greater than 0, happens to be between, this is 0, happens to be all the numbers in between -4 and +3. Yay! We did it. Ta-da! Let's do it again. Oops, what happened? Let's do it again. So I'm going to have to clean out all my stuff. We don't want any of that there. Wish it would all clean off at once. Is there a way to make it all clean off at once? This might be faster. Oh, yeah. Okay, so we'll do this one. We'll do 32. Get rid of that business. Okay, so what's going on in 32? Well, I can see that the x-intercept is 0, 0. And that's right there. X-intercept is 0, 0. So I know that. And then I can see that it's positive on this side of the asymptote, negative on that side of the asymptote, negative on that side of 0, and positive over there. So what have I got? I've got an asymptote right here. What are we counting by? 2, 4, 6, okay. So this asymptote's at negative 4. There's an x-intercept at 3, and then there's another asymptote at 4. So we're cutting our x-axis into 4 spots, right? So what's happening over here, from negative infinity to negative 4, that graph is positive. You agree? Yeah. And then look, from positive 4 to positive infinity, that graph is positive as well. Are you agreeing with me? Yeah. So when is it negative? You say all the numbers between negative 4 and positive 4. And I say, nope, you were wrong. Because it's not negative when it's right here in the middle. So the answer to when is this graph positive is these two times, right? When is the graph negative? It's not just one big thing that's negative. No siree. It's from negative 4 to 0, because once it hits 0, it's not negative anymore. And then on the other side of 0, it's negative again. So there's 2 places that it's negative, and there's 2 places that it's positive. Okay? All right, let's look at one more. We'll look at 33. Well, we don't need that one anymore. And let's find my eraser again and get rid of this business. Boop, 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 boop. There we go. We don't need that business. All right, so we're looking at number 33 now. 33. Back to this. So, does this have any x-intercepts? No. No x-intercepts. No x-intercepts. But it does have an asymptote, and here we're counting by 1, 2, 3. So that asymptote's at 1. Positive 1. Okay. So that means we get to cut our x-axis into 2 pieces. So what's happening on this piece? Well, from negative infinity to positive 1, it looks like it's positive, right? Positive the whole time. And then from 1 to infinity, it's also positive. Ha 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 ha. Looks like it's always positive, right? But you still have to answer these 3 questions. When is it equal to 0? Your answer would be never. All right? So if it's never equal to 0, you have to say that. When is it positive? Well, it's positive between negative infinity and 1. Remember, there's no answer at 1. You can't say it's positive from negative infinity to positive infinity because there's no answer at 1. And then how about when is it negative? Well, never again, right? Never, 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 never. Never. Right? So, that's what we're doing today. You're answering these 3 questions for every graph they give you. So, what are the important things you need to know? You have to know the x-intercept and you have to know the vertical asymptote because it all hinges on the x-intercept and the vertical asymptote. Remember down here, the x-intercept divvies up between the positive and the negative side, and then the x-intercept, that was the vertical asymptote, divvies that The x-intercept divvies this negative from that negative, and then the vertical asymptote divvies up this negative to this positive, right? So, whenever you're answering the questions, you have to be able to tell me, oops, I didn't answer the third question. You have to be able to tell me where is it equal 0? That one's just x equals 0, right there. Boop, 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 boop. When is it positive? And when is it negative? There we go. So, that's today's homework. See ya.